Hello students and parents, Mr. White here, going through our Chapter 8 practice test. It's a walkthrough to really help you make sure that you are able to understand what we've learned in this chapter, so it'll be a great way to review everything as well as prepare to study. Just really here to help you out in any way I can, so I really do hope that this is helpful. We need to show our work. We're not using calculators. Round to the nearest tenth or cent when necessary. We're going to see that pretty soon early on into this. So let's go ahead and get started. I think the first part will be pretty decent, but I know towards the back as we get to percent change, that is where it has been a little bit trickier for this class. So go ahead if you need to and you feel confident for the front, you can go through this pretty quick and then get towards the parts that you need the most help with or that you need to really go over the most. So starting off, right, 45% as a decimal. Well, to do that, we need to divide by 100, which means going 2 to the left, 1 and 2. So, decimal point 45, that'll get us there. Then let's do the opposite. Write 0 decimal point 6, 6/10 as a percent. To do that, so we divided to get to the decimal, but now we need to multiply it by 100. So multiplying, we got bigger, so we go to the right. So we go to the right, 1, 2, add the 0. So we would have 60%. The next one there, write 3/5 as a percent. One way we learn to do it, which will probably be the best way going forward if this bottom one can easily go into 100. That is one way you would do it. So I'll set that up as 3/5 equals what over 100? 5 times what equals 100? Well, 5 times 20 does, so I can multiply the top also by 20 and see that it's 60 over 100. And we learned if you have 60 over 100, we would just say this is 60%. The other way you could do it would be just the long division. So 5, and then the 3 goes inside of the house. Can go in there 6 times. So I'm left with 0.6, just as I was in this one. So then I would need to multiply it and get 60%. One thing, I'll say this all throughout this, but it's very important you know the top number goes inside of the box, inside of the house. Number 3 is up high. Number 3 is scared of the heights, of being up high, so he wants to jump down and find safety inside of the house. I've been saying that all this year, and unfortunately we're at chapter 8 halfway through the year, and some students are still kind of forgetting how to do that. So it is going to be super important though in this whole chapter and really going forward in math. Next one here, write 12.5% as a fraction in the simplest form. How I went ahead and did this was I moved it over 2 to get it into the decimal, and I see that this is, so that's a tenth, hundredth, thousandth. So I can then put 125 over 1,000th. So this digit there is what's telling me why I need 1,000. And then from there, I just need to reduce it. So let's divide by 5 to start, because I know for sure 5 can go into that. And that gets me 25 over 200. And then let's also divide by 25. And 25. If you did that, you would see that it comes out to 1 over h. So it's systematic. You just got to keep on going down. You could have just slowly gone down, like by 5, by 5, by 5, until you get there. But this is just for the purpose of how I did it and worked it out. All right, this one right here, write it as a percent. We have to use this method because 6 doesn't easily go into 100. So where does the 1 go? Tell me now on your screen as you're watching. The 1 goes on the inside of the house. It is afraid. All right, and I know it's not going to go into 1, so that's why I add the decimal point and a couple zeros, because we need to see how far is it going to go. 6 can go into 1 0 times. How about 6 into 10? Can go in there once. Before 0. 6 times 6 is 36. And then what is this? We start to see it's just repeating. And it is just going to keep on repeating. So I'm going to stop there. I'm going to look up here. It says round to the nearest tenth. So if I'm going to make this into a percent, I need to 2 multiply it by 100. So I have 16.66%. But rounding to the 10th, we're looking at this right there. And I'm saying, is 6 greater than 5 or less than 5? It's greater than 5, so we can actually round up. 16.7%. All right, that's the first section. Continuing on from here, I would say with all of these, and this is another thing I've said so many times, and I've seen, even as I walk throughout the classroom, students are still not putting it on, and I'm like, you guys, this is such a great tip. And I remember my teacher way back in high school, and that was a very, very long time ago, let me know these things too, and I've kept it with me, and for me, it really, really helps me. So if we see the words of, that's the same thing as saying multiply. 30% times multiplied by 80. So my suggestion as you get to tests, assessments, quizzes, anything going forward is just go ahead and add that so that you know. Because it looks confusing if you say find 30% of 80. You're like, Mr. White, I don't know how to do that. I'm like, you do. You do. Do not worry. You do. So I'm just going to go ahead and change all of these. So we need the percent into a decimal. So 0.30 times 80 equals what? This one here, we need to move over 1 and 2. So 0.125 times 64 equals what? And this one here, 0.005 times 200 equals what? So that's what essentially we're looking to do. That's what it's asking us to do. So if we work through this, we have 0.30. And I can't say that it's 2,400 because look, there's a decimal here and I have 2 spots, 2 places. So I need to go 1, 2, bring it over and find that it is 24. This one here, this one takes a little bit longer, so you do need to be patient. But see, I have 3 decimal places, so remember that as we come back to it. 0, 2. So 0, 0, 0, and 8. Can I say that it's 8,000? Nope. Why? Because there's 3 decimal places. So I need to go 1, 2, and 3. So I could say that 12.5% of 64 is 8. All right, from there, the last one here, so I have 5, basically 5 thousandths times 200, but I'll just do 200 times 5, 0, 0, 1, 0. And then I need to remember there's 1, 2, and 3. So 1, 2, 3, 1. A very small number. Okay, last 3 from here. Same idea here. Let's add the times sign because I know that's what I need to do. From there, let's change these percents into decimals. So at 0.25 times 60, I have 0.002 times 500. And here, 1, 2, I have 1.4 times 50. And so if I see such a small, this is a tangent, 25%, that's a quarter. So I know about a quarter, I'm gonna look for in the number and ask myself, does that make sense? Is it about a quarter of it? If so, then probably we're on the right path there. And if not, then it might have been done wrong. How about 0.2%? That's such a small number. And then when I change it to a decimal, decimal 0.002, 2,000ths, that tells me it's probably going to be a small number. And then 140%, 1.4, that's over 100. So that means this number is going to be bigger than 50. So those are just little things that you pick up, clues from the problem, that will help you check your problem as you get back to it. So let's go ahead and get this done. So 1,500, no, we have 2 places in the decimal, so we go 1, 2, 15. All right, this one, let's just do 500 times 2, and then I need to remember that there's 3 decimal places. So 0, 0, 1, 0, 1, 2, 3. So 1. And then this one here, we have 1.4 times 50, 7, and then I need to bring it over 1 because there's just one decimal place there, and 70. And so this one, you're like, it's bigger than 50, but look, it's 140%, so it needs to be over 50. So that's how that works together, and this is the first page. Main things I would say, make sure you understand that the of means we're wanting to multiply it. That's huge. And then make sure we know that if we had decimal places, we need to move it over at the end. Those are two big things. Okay, page 2, it's getting to the next steps of what we've learned. We need to create basically little equations from what we're given. So what I would do and what I would suggest is go through and label everything of what you know it is. So times is above the of, is the same as saying equals. And I would really suggest we are doing that for all of these. It will save your life when it comes to this and make it a little less scary. If you, I mean, it shouldn't ever be scary, but like help you so that you don't maybe panic or get worried or concerned if you see this and you're like, it's just a bunch of numbers but also letters and it's what am I supposed to do? You'll notice I circled what percent because, as I've talked about in class and in the other videos, I love these ones because it's telling you what percent. Saying like we're looking for the percent, so we know this is the part and this is the whole number. So those are tricks. Here I'm given a percent, so I can go ahead and change that into a decimal to start. So anytime you see that, you could also do that as well. And these are percent, so that's what we're looking for. 30% times what number, so that would be the whole number, equals 18. Now, I'm always just going to rewrite this, and going forward, I'm going to just squish them together because that's how we're used to seeing them. So 0.30w equals 18. Once you get it here, my hope is that you are very confident in knowing how to isolate it, because that's what we've done this before. So for a couple chapters. So w equals 18 divided by 0.30. Which one goes inside the top number? He's afraid. Maybe I have to think of a new thing of not being afraid, because that doesn't seem to be helpful. But maybe as you get older, you'll be like, wow, Mr. White, that was super helpful. All right, so this, can we have a decimal on the outside? No. We move it over 1, 2. So 1, 2, that adds 2 zeros. So now we're looking at 30 and putting it into this number. Doesn't go into 18. Nope. 180 though. 6 times 30 is 180. 0, 0. Can it go into 0? 0 times. No. So that would tell us the answer is 60. Hooray! All right, and then if you really wanted to check it, what you do is plug it in. So if this was what we started with equals 18, we plug 60 into here, and we're asking, does 30.30 times 60 equal 18? Let's check it out and see. I'll do it over here. We're running out of room. 3, 0, and 6, 0. 0, 0, 18. And then there's 2 places, so I need to move over 1, 2. So yes, it does. So I know that that one is correct. This one, 12 equals 40 times what number? 40w. So we're used to seeing it like this typically. So I always just rewrite it like that. For me, that helps a lot. I think I'm gonna sneeze. It's coming. All right, so we divide both sides by 0.40. All right, bless me, or bless you? No, I don't know. So where w equals 12 divided by 0.4. Can this stay on the outside? No, it cannot, so move it over 2 times. 3, 3, 0. So that would be 30. And if you have extra time on the test, go ahead, test it out. Is 0.40 times 30 12? You'll see that yes it is. All right, this one, 24 equals what percent of 80? So I will just rewrite it as 80p, because we know that this is the variable of the equation. That's what we're missing, so it becomes a letter. So if we have 24 equals 80p, then we need to get it by itself, isolate the variable. So p equals 24 over 80. 24, the top number, goes inside. And then I know 80 doesn't go into 24, so that's why I'm preemptively adding the decimal point right there. But I know 3 times 80 would be 240. Amazing. And then it's just a bunch of zeros after that. So what percent? Multiply it by 100, and we'd see 30%. All right, this last one in this section, 9 equals what percent of 60? So I'm going to rewrite that 60p, divide by 60, divide by 60, 60, and then 9, the top number, goes inside. So 60 times 2 would be 120, so that's already too big. So let's do 1. And that would get us 300, well 2. No, 5. 2 would be 120. 5 times that would get us 300. So 0.15, but I can't put the answer as 0.15 because look, it's asking for what percent. So let's multiply that by 100 and we see it would be 15%. So that's the first part. Continuing on from here, we have find the amount of change. So that's what it's asking us for, and state if it's increase or decrease. So we need two parts to this. And the amount of change is going to be what we need to use as we get to percent change. So this is kind of prepping us for what we're getting into. So to find the amount change, you just need to figure out how do we get from 50 to 65? Well, easy way to do that, 65 minus 50. You see, it's 15. All right, that's the amount of change. And then if it's increase or decrease, you're asking yourself, to get from 50 to 65, am I going up, increasing, or am I going down? Well, 50 going up to 65, we're counting up, so that would be an increase. All right, 17 from 120 to 90. Just go ahead and subtract, and you'll see that it is 30. So that is the amount of change. Then we're looking at the original amount right here. The first numbers, these are the original. That's what we started with. So when we say original, what did you start with? We started with 120, and then we went down. We counted down. We subtracted 30 to get to 90. So that would be a decrease. Okay, now we're down to the bottom of the page. Percent change, that's what it's asking us to do. And also state if it's an increase or a decrease. So very similar to this. And we actually do need to find the amount of change to help us with this, because this is what you need to memorize, is amount of change over the original amount. That is our formula for the percent change. So if I were you, as soon as I get my test, I flip back to percent change and I just write this down because that's going to help me out so much. And then right above, we just did amount change. How do we do that? We figured out what is the difference between the two numbers. So for each of these, just figure out what is the difference between 40 and 50. So do 50 minus 40, we'll see that that's 10. So then 10 is the amount of change that goes on top. Then what goes on the bottom? The original amount. This is nice and it tells you original. But we'll get a little bit harder as we keep going. But the original one is 40, just like 50 was the original and 120 was the original. So 40 goes on the bottom, and then we need to make this into a percent. So we need to reduce it. I divided by 10 by slashing those. So we have 1 over 4. 4 into 1 like this, we'd see a 2. 0.25, move that over to get to a percent. So we would have 25%. And then lastly, this part right here, from 40 to 50, are we going up or are we going down? We are going up. So that would be an increase. So this is my answer. I need a percent because we're looking for percent change. And I need to know is it increasing or decreasing. And we need to know this. So star this, write this 10 times, 20 times, however many times it takes for you to memorize it, because you're going to need to know this. In my consumer math class, which is for 12th graders, we cover this as well. And guess what? Same equation right there that you would be using. All right. Sorry, there's a mosquito or something landing on the screen. We cannot have that. No, no, no. All right. First thing, find the amount of change. 80 minus 60. So 20. Amazing. We're already almost there. Original amount is 80. So I plug that down at the bottom. Slash that out. Divide by 10. We have 2 over 8. Make that smaller into 1/4. Ay, 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 can you believe that? 2 1/4. It will not be like this on your test. Don't think that you're going to get by that easy. No, no, no. It's not fun if it's like that, right? We already know it's 25%. And then 80 to 60, is that going up or down? 80 is going down to 60. So it would be a decrease. So that would be my answer. Last one here, find the amount of change. So our first step. So 30 minus 25, there's a 5 change. So 5 goes on the top because we have memorized this at this point. Amazing, great job. Original is right here, so that's 25. And then let's make that smaller, reduce that to be 1 over 5. And then maybe you know 1/5 as a percent. If not, here's the quick way. 1/5 equals what over 100 times 20 times 20. And then we know if it is, so I did 5 times 20 to get to 100, 1 times 20 to get the 20 on top. Once it's in this format like this, we can say that this is 20%. So we would say it's a 20%, and we increase because we go 25 plus 5 to get to 30. 20% increase. And I did not mention it, and I'm sure you can maybe tell, but I am outside. So that is why there's a mosquito. No, it's not in my house. And why you maybe just heard the hummingbird that was getting a drink from the hummingbird feeder that is out here on the porch with me. So flip the page over. We're on page 3. We're getting close. We're, I guess, halfway. I almost just swallowed a fly. Wow. My, oh my. The boy who swallowed the fly. Okay, now we're getting to where, at least this first time of me teaching the class, students started getting some questions and a little bit confused, because now we're in the part of getting to the real world applications. So percent applications in real life. Where would you see some of this stuff? Well, we'll see it when we come to sales and discounts for things we're buying. But the discount, maybe we'll just put it here. That's what you get off. What you get off the price. And then the sale, that will be what you actually pay. So, if that does not quite make sense, here's an example. So, I'm going to buy, this is the dog's toy, this ball thrower. It's tiny because he's a tiny little dog, which if you've seen my PE fitness videos on this account, you've seen Teddy. Well, ooh, maybe we need a new one. Maybe that's the story. We need to buy a new one of these. So we go to the store and we see that, you know, let's just say it's $20, but it has a 10% discount. Well, in that context, it's $20 and it gives a 20% discount. Did I say that right? I gotta write it down, you guys. I've caught a cold and my mind is not quite working. So I'm like, why am I going into some complex story? But hopefully this is for you. This is to help you. So $20, which is way too expensive for this, but that's a 10% discount. If I find out what the discount is, so if I do the math, 20 times 0.10, or actually I think I could do it like that easier. And 1, 2, bring it over. So I see the discount would equal $2. Am I paying $2 for this? No, I'm just getting a discount of $2. So when it's asking find the discount, we're just wanting to know, you know, in this it was 20 times 0.10. 20 times 0.10 because I made the percent into a decimal, and I found that it was 2. So I'm not paying $2, but I'm going to get $2 off. So if I went to the store, I saw this, for $20, I can get a new one of these, but I'm in luck. There's a 10% discount. I figured that out, and I see, okay, the discount is $2. So great, I'm going to save $2 on this. But what is the sale? Like, what is the sale price? What am I actually going to pay? Well, what I'm going to pay is $20 minus this discount. So 20 minus 2. So the sale that I get is the original price, original, if I can spell, minus the discount. So that's something, I know I wrote on the wrong end because I need to show work for these. Original minus the discount. So the original is 20 minus the discount, which we just found was $2. So I'm going to be spending $18 for this. So the discount I got was $2, but I'm not paying $2. The sale price, though, was $18. But I need to know what the discount was in order to get that. So like in this, it's saying find the discount. So 20% off of $60. Thank you, Teddy's Toy. You may exit the stage. 20% off of $60. This is the same as saying 20% times 60, because we just want to know the discount. I don't need to know what you're actually paying. I just want to know, what are you getting off? Like, what are you saving? So that would be 0.20 times 60. We set that up like this. Bring that over 2, because there's 2 spots. So $12. That is the discount amount I would get. This next one, though, we want to find the sale price. And so there are 2 different ways you can do this. I'm first going to do it this way because that's typically how my mind thinks, but there's actually a faster way that some of you, hopefully if you're learning this for the first time, you will just stick with that because it seems so much easier and more efficient. But Mr. White here just learned it this first way, and I just always revert back to that. But first thing we want to do is 0.15 times 80. This is because I am right now just looking to find the sale price. Or what I want to end with is the sale price. What I'm finding right now, so there was 2, so bring that over, is the discount price. So the discount is going to be $12. And then the last thing I need to do is what I put over here, original minus the discount. Because I want to figure out not just what I'm saving, but what am I actually going to pay? What is the sale price I will be paying? And I see 68. Other way you could do this one is by saying, all right, 50% off, I'm going to get that much off of this, but what am I going to pay of this price? Well, I'm going to pay 100 minus 15, 85%. That's how much I'm actually going to be paying. So in this second method, which is faster somewhat because typically a lot of us could do 100 minus 15 pretty fast, but even if not, look, 100 minus 15, 85. That's much faster, I think, than doing this. But once we have that, we would say that that's 85% times 80. That's what I'm actually going to be paying. So in order to do that, then we just do the math there. So 0.85 times 80, a 0, 68, and we bring it over 2. And guess what? We found 68. Boom. So to recap, the second method is, do we need to pause for the helicopter? I think it's a helicopter. Oh yeah, it is. It is a helicopter. Flying over the backyard. Oh joy. All right. Is 85% of it is off. So let's flip that around and figure out, okay, we're going to get that off. What are we actually paying? We're paying 85% of this $80. So maybe that's helpful, but if not, just go back to this, take it step by step, and figure out first what is the discount, then do original amount subtracted from your discount. Okay, we're gonna move a little bit faster, but I do hope that that was a helpful explanation. From here, a jacket costs $90 and is discounted 30%. So first thing we want to do is find the discount. So that would be 0.30 times 90. 27. There's 2 decimal places, so let's move that over. So $27. And then the sale price, we just subtract. So 90 minus 27. There's Teddy. Let's see if I can. Teddy! There he is. Oh, he's so excited to be in this video, you guys. I hope you enjoyed that. See, math can be fun. Math can be exciting. All right, 8 minus 2 is 6. So 63 is the sale price. So in this scenario, a jacket costs $90. The discount we're going to get, if it's discounted 30%, is $27. I'm not paying $27. That's how much I get off. So that means if I want to know what am I actually going to pay, I need to do 90 minus 27, and I'm going to pay $63 for this jacket. It better be a nice jacket. That's all I can say. All right, find the markup and the percent of markup. This is what was also confusing. Think of this as the amount of change, and then the percent of markup, think of that as percent change. We are looking at this as you would see it in real life, and that's how you would talk about it. Like, what was the markup? What was the percent of markup? Like, how much did they change it? The percent change. So we're going to be doing the same thing, though. Don't you worry. So amount of markup, if it's the same as amount of change, we just figure out what's the difference between this and this. 50 minus 40 is 10. So we marked it up $10. We increased it. Markup is the same as increase, so we increased it. So it's taking what we just did on this side and just putting some different words, so don't be confused. It's all right. You can do it. That's the first thing. And then what was our equation for the percent change? We have the amount of change on the top, and then we have the original amount at the bottom, 40. 1/4 equals 25%. So no, it won't be like this either. I realized as I was going through it, I'm like, why do so many come out to 25%? But I think the nice thing with this is it helps ease you into it, because I do know this can be a little bit tricky for some of us. But continuing on from here, a video game is marked up from $30 to $36. So find the percent markup. It's asking find the percent change. That's what I want to do. So 30 to 36, the difference between that, the amount of change is going up 6. So that will be at the top. And then the original is 30. Let's reduce that. It's 1/5. You could do the math and find that that would be 20%. Amazing. Okay, from there, this last section we're going to start with, but our instructions, you see the fly that just flew in front of the screen. Read the following problems carefully and then solve each one showing work. So these are going to be maybe a little more difficult, but it's part of the word problems, real world application stuff of how you'd actually see this. So just think through and think back of everything we've done, and then bring those elements to what we're going to go into going forward. So with that in mind, let's go ahead and read through each of these very carefully. A student earned 45 points out of 60 on a test. So that's like if I grade your test and you get 45 out of 60. Okay, cool. We can set it up like that. All right, from there, it's saying what percent did the student earn? And I actually do this with all of the tests I give back. I give you the percentage, because if you see 45 out of 60, is that good? Is that bad? I do not know. Maybe that's what you're thinking. You got 15 wrong, so it's not like an A, I can tell you that. But what is the percentage? Well, what we could do from there is we can either reduce this, or we can just jump right on into it. Let's try reducing it. I know 5 can go into both of these, right? Yes, because it ends in a 0. Divisibility rules. 9 over, man, I'm really not thinking well. 12. It's 12, Mr. White. Come on. I'm sure you're yelling at your screen right now. It's 12, Mr. White. Hang in there. You're almost done. Thank you. I appreciate the support. 3 over 4. Some of you might know, like 1/4 is 25%, so 3/4 would be 75%. But say we didn't know that. We do not know that. The 3 goes inside. Please remember that. 4 times 7 is 28. 205. 0.75. Our answer is not 0.75%. No. We multiply that by 100, and we say this student earned a 75% on the test. How cool, you can now figure this out. So if I don't give you the percentage, you know how to do that. So 75%, that's a C. So I guess the world calls that average, but hopefully you're aiming for an A or a B. But also, as we've talked about in class, you shouldn't be so focused on what other people are getting, but more so, are you learning the material? Do you understand it? I would also even add to it, are you having fun with it? Because you're going to be in math for quite a while, and if you can learn how to truly appreciate and have fun with math as you're going, it's going to make it so much more bearable, no, more enjoyable as you keep on going in your education. So this one, a bike originally cost $20 and is on sale for $150. So it's on sale for $150. So how much did it decrease? Find the amount of decrease. 200 minus 150. Another way, the amount of decrease, it's the amount of change. So instead of amount of markup going up, it decreased, it went down $50. So $50. And then find the percent of decrease. Same thing that we need to do as we have been doing is we have the amount of change. So we have 50. And then it needs to go original amount at the bottom. The original amount of what it originally cost was 200. Then we make this smaller, divide by 5. It's 1/4. I know I am also very sick of seeing 1/4 and 25% everywhere I go. So don't worry, you won't see that on the test. But I really do hope you understand what we're doing. So it costs this, and then we have less. So what is the amount of decrease or the amount of change? It's 50. We just subtract and see how much did it decrease. Then the percent of decrease, same thing as saying percent change, which we did on the previous pages. Amount of change goes on top, original amount at the bottom. You just work it down to a small enough fraction, or you could just do that right there if you want to do 200 into 50, and then eventually you would get 25 as you kept going. All right, 28, we're almost there, hang in there. Last year, a club had 40 members. This year, it has 50 members. Oh my goodness, this is the same. I'm definitely changing this. Well, maybe not, because then I have to make a whole new video. Oh, you guys, what a tough position to be in. You're like, boo-hoo, Mr. White. Okay, last year, a club had 40 members. This year, it has 50 members. Find the percent change. So first thing I need to do is find the amount of change, 40 to 50. The amount of change of that is 10. And then the original was 40. 1/4, 25%. I am so sorry. And it was an increase because we went up. All right, backpack costs $75. Seems kind of expensive to me, but yet again, I'm not buying backpacks these days. A store offers 20% off. What is the sale price? So we want to know, sale price, what are we actually going to pay for it? So what we can do is either, I guess I'll do both methods. We've got time, right? So the one that I said I remember growing up, we would do 75 times 0.20. So we made this into 0.20. So this is me finding first 14.15. The discount. So the discount is $15. And then the sale price is the original amount, 75 minus the discount, which would be 60. Other way I can do this, which might be a little bit faster, is I know it's 20% off, which means I'm going to be paying 80% of this final price. So I could also do, and how did I get 80%? I did 100 minus 20. I got 80. So I would do 75 times 0.80. And I got 60. So either one of these ways works. However it makes sense to you, please use that. Or if you want to check, you could do both methods and see, I got 60 here. What if I did it over here? Do I get $60? Yes. Hopefully, and then great. Last one. A store buys a pair of shoes for $50 and marks them up 40%. What is the selling price? So same idea here. We want to know how much would you buy them for? They mark them up. So it's going up. It's an increase. So let's start with that. This would be 40, and I just want to multiply it because I want to know how much is it. Going back of what we saw before is the same thing here. 20 and then two decimal places. So they're marking them up $20. 40% is the same as saying $20 in this scenario. So $50 is marked them up 40%, or they're marked up $20. So to find the selling price, we need to add now 50 plus 20, because we're adding the original price plus the new price that we've marked them up. So the store was like, oh, everyone loves, what do they love? This pen right here. Wow, this $50 pen is just flying off of the shelves. So we could be getting more money than just $50. Let's mark it up. How much do we want to mark it up? Let's mark it up 40%. Marking up 40% means that we're going to add an extra $20 so we can get more money for this pen. So I'm not paying $20, no, because we want to get more money than the $50, but we're marking it up 20. So 50 plus 20 means that in total, customers will be paying $70 for this pen. Wow, what a beautiful pen. So that is what the selling price would be. And actually, these pens were like $1 for like 12 of them at Target during the back to school sale when I first began teaching or getting ready to teach. So, no way I'd pay that much. But there are calligraphy pens that this would be very cheap. Can you imagine that? Wow. All right, that's it. Hopefully this was helpful. Take your time, please, to go through this, practice. You can go through your notes, your textbook, just everything we've gone through, the review sheets, to really help you learn these concepts. So I do hope that was helpful, and we'll see you in class.